Right, you should have all of Module 1 complete at this point. The test was due yesterday, last night, and that would be parts 1 and parts 2. Parts 1 and 2. Most everyone has it done, but not exactly everyone. Some people do not have all of it finished, so there are a couple of folks that are behind. Several of you have it turned in, and I've got to grade it now. So I'll be doing a lot of grading in the next day or two, trying to get caught up on those so I can get them posted in the grade book for you. So it'll be in the Home Access Center, and most people did pretty well. Good start for most. A few people didn't do quite as well, and we'll have to look at that. For those of you who need a grade boost, let me get that pencil sharpened up. All right, we are starting the second unit, and it looks a little different in Buzz. So I wanted to show you that this morning, and then talk a little bit about what is in this week's lesson, as well as what is due this week. All right, so looking at our Algebra 3, let me go to our grade screen first off. Okay, right here, September 19th, that's Sunday's date. We have lesson 201 and 2.02, so functions and graphs of functions. So we're going to be looking at those two lessons this morning, just briefly here. I'm going to show you what they look like. Like I said, they look a little bit different. This is borrowed from some pre-calculus stuff. Pre-calculus went over functions. And so Algebra 3 is a course that we've had to kind of build. We've built it because it doesn't exist in the Florida virtual world, which is we use Florida virtual curriculum for most of our virtual math here. And Algebra 3 is not a course that they have. So we've pulled together everything that we teach in Algebra 3, and we borrow it from other classes that are taught, because they teach the stuff, but they break it up into different classes. So in this, all of your lesson is on one page. I say one page. It's like 7 pages long, but it's all here on the same screen. You have to scroll down. There's no flipping. There's no clicking on going to another page. It's all right here when you go to the lessons in this unit. So in unit 2, it'll all be right here. And the way they break it up right here is you have the scenic overview. All right here at the beginning. And the scenic overview is all the stuff with the blue highlighting, and it goes down until you get to where the page changes and looks like this. So everything above this, all this up here, is really your lesson summary. You get your lesson summary at the beginning of these lessons. So this right here will tell you what you're looking at, and then you get down to the lesson, and this goes into more details and gives you more examples and shows you more extra figures and things to illustrate what it's talking about. So this is laid out a little differently in the fact that you get the lesson summary first, and then you get all of the detailed information in the lesson second. And there are some different examples that you go through. Now, as far as your practice, because there's usually always practice in these lessons, we do have some practice built up here in the lesson summary. Like right here, it's got, it says check your answers. Says test your skills. Use the set of values 1, 2, 3, 4 as a domain, and the set of values 2, 1, 0, 1, 2 is the range. Which of the following ordered pairs is valid functions? So you got to look at that and figure out which ones are. It says check your answers. So that means if I click on that, it pops up another document. And if I click on that document, it'll take me there and give me the answers so I can check to see if I was right or not. There they are. Check your answers. So right there, it'll have all the answers to that. So there's a few of these places you'll see check your answers. Here's another practice problem it gives you. check your answers, click on that. That takes you to another document. Here's another one, test it, check your answers, another document. So anywhere that's there, we have the other document there that does have the answers. So you still have some practice problems in the lesson to where you can go and say, do I understand this? Let me see. Can I determine the domain of the following? And so I'm trying to get the domain and I can go check. You probably ought to do all of those in that box before you go check, because all the answers are on the same page. So if you check the first answer, you'll see the second answer right there underneath it. And that might affect how you do that problem. So work all the same ones in the box on paper before you go check the answer, because all the answers are right there and grouped together. But let's talk about what it is saying as far as a function. So we're talking about going back to what is a function and what is the properties of a function. And so looking at our lesson summary, let's see if I can make that a little bit bigger. Yeah, that gets a little bigger. Some of the lessons are a little bigger on the screen to start with. This one I just had to blow up. Just change your view. So talks about functions in our lives. If we drive on interstate at 70 miles an hour, we'll go into Yosemite National Park, how far we travel in a given number of hours. That would be a function. If we purchase a certificate of deposit paying 4.5% interest per year, how much would it be worth after a given number of years? That's a function. And you can illustrate that with a table. Like, here's our miles. After 1 hour, we've driven 70 miles, 2, 140, 3, 210. You can take this table and make points out of it. The point 170, 2, 143, 210, all of that. And that means we could also graph that, right? So we can present a function as a table or a word problem or a set of points or a graph, many ways that we can present a function. But what is a function? So here it is. Here's this mathematical terms. Let's read the mathematical definition. A function f from a set A to a set B is a rule of correspondence that assigns to each element x in the set A exactly one element y in the set B. The set A is the domain or the set of inputs of the function f, and the set B contains the range or set of outputs. Real mathy college level language there, right? It's like, what in the world did you just read, Mr. Brock? I have no idea what you just said. Basically what we said is that means if you have a function for every x, there's only exactly one y. For every x, there's only exactly one y. There's no x that has two different y's. If you look at the points, if x is a point 2, 6, you won't find another point that has 2, 8, because 2 only is going to have one y value assigned to it, and that was 6. If you find 2, 6 and 2, 8, that is not a function, because that x value has two different y's assigned to it. So that's what a function is. If you graph it, there's only going to be one. If you make a line straight up down, there's going to be one place that crosses that graph, and that's actually in the next lesson. So all functions have the following characteristics. For each value in the domain, which means for each x, there's only one corresponding value in the range. There's only one y. For each x, there's only one y. That's what it breaks down to. That's a nice, easy language. All elements in the domain must be used, and more than one value in the domain can be matched with the same value in the range. So let me switch to my document camera, and let's talk about that with just some examples on paper, just to make that a little easier to understand, perhaps. Okay, so it's saying there's only one x for each y. So let's look at it with a table. We can present a function with a table. So if we're checking to see this is a function, and we have -2, 1, 0, 1, 2, and it's assigned to 0, 2, 4, 6, and 6. Okay. We look at this and we're trying to say, is this a function or not? And right away we look at it, we say, well, we know there's only one y for each x, and this right away catches our eye. Wait a minute, there's 2 6s on there. So does that mean this is not a function because there's 2 6s? Well, the definition says there's only one y for each x. The 6 goes with the 1, but is there any other y's that go with the 1? 1 only has one value attached to it, right? It's an x, so it should only have one y. It does only have one y. Now, number 2 also has the same y. It also has a 6, but 2 only has one value. So as long as x only has one value, they can all have the same value. All of these could be 6. They could all be 6. That would be fine. If we graph that, that means it would look like this, right? It would be up at the 6, where 6 is right here, the y. That's a function. That's fine. It's a straight line if they're all 6s. You just can't have, like down here, 1 would go with 8. So if we said 1 goes with 6 and 1 goes with 8, that means over here at 1, there's also a point up here that's on the graph. So maybe our graph circled around like that, right? I just circle around back here. You can't have 2 different points on the graph. You can't have 2 different y's for the same x, or it's not a function at that point. So that's the way you look at it. Is there only one y? It doesn't matter if it's the same y. We can only have one y. So the other things we talk about is the domain and the range of a function, right? So domain, we're talking about properties of functions. The domain and the range. Domain is all the possible x's. And the range is all possible y's. So the domain's all the x's, the range is all of the y's. So when we talk about the domain of this, if all of these, let's erase this one because it's not a function when I added that one, right? So the domain of this is -2, 1, 0, 1, and 2. That's the domain because that's the only thing we have. That's the only thing we have. We graph like this, but actually for this table, we would only graph the points. The line would only be if we were trying to figure out y equals 6, right? Y equals 6 would be the line, and then we do the whole line. If we don't have this right here, maybe we're trying to make a table of this equation. If we don't have the equation and we only have the table, then it's just the points. We don't have the line. The line doesn't exist. But the range in this case is 6. Right? For the table, that's the only possible y. They all have the same y of 6, but they have these 5 x's. If, let's go back to the y equals 6. If we're using this, we're not using the table. We're using the graph of y equals 6. The range is still 6. That's still the range because it doesn't go any higher or lower than 6. But now for the equation, our domain goes from -infinity to infinity and beyond, right? Y equals 6 goes from negative, them arrows go from -infinity to infinity. So if you have just a table, your domain is just the points like this. If it's an equation, then you got to look and see, does the equation, if I graph it, does it go forever? Is it a line? Could go forever. Could be a parabola, all right, because we have parabolas. That could go -infinity to infinity, right? Doesn't have to be a line, but you just have to pay attention. And on this, the range would be whatever that value is, -infinity all the way up to that value, but no higher. Domain and range. So this lesson goes over domain and range. We also talk about function notation. Since we're talking about functions, if we write this in function notation, we would write it f of x equals 6. That's function notation, where we take the y and we replace it with f of x. They mean the same thing. When you see f of x, think y. Y equals 6. Means the same thing. But this is in function notation. It means that's how we write it as a function. Function of x equals 6. So we'll have that. So we look at the function notation. We look at domains. We look at ranges. You got to be careful with domains. If we have, let's say f of x equals, and so some of this will talk about what is the domain and range of it. So what if we have 1 over x is our function, right? And we have to look at that. We say, okay, so what's the domain first? Domain. Can it be negative infinity? Sure, we can have a -1 million. It can be -1 over -1 million or whatever, 1 over -5 million. We could have just 1 over -1, that equals -1. But the only thing we can't have, if you just have x down here, it's all real numbers. Could be anything. It could be a 0.5. all real numbers except 0. We can't have 0. You cannot put 0 in the denominator. 1 over 0 does not exist. So the domain's all real numbers. I'll put an S in all real numbers except for 0. All right, or we could say negative infinity is less than x. I'm sorry. We could say negative infinity. Let's write it in the proper notation here. Negative infinity to 0 and 0 to infinity. But I use parentheses because 0 is not included, right? If 0 was included, we say negative infinity to 0 and we put a bracket. Bracket means include the 0. But we can't include the 0. It's only this and this. Right? It's this. And in math terms, we'll learn to put this in between there. That means both of those, union. We haven't got to that. We'll talk about that. Negative infinity to 0 and 0 to infinity, but not counting 0 itself on this. So domains and ranges. We're talking this lesson about how to figure out what is a proper domain and range. So the other things that we'll talk about in lesson 2 is when you graph functions. What does it look like when you graph a function? So we were looking a little bit of it up here, but the scenic overlook, we'll give you a link on there to Desmos. If you haven't used Desmos, it talks about graphing functions. So things we talk about when we're graphing is we talk about it being increasing or decreasing. Right? Is it an increasing function? Is it a decreasing function? And generally that means the right side of it. As it goes to infinity, is it going up and increasing, or is it going down, or is it constant? If it doesn't increase or decrease, it's constant. But if it's going up or if it's going down, it's increasing or decreasing. Right? It does go constant if it's flat. But increasing and decreasing, that's other properties that we talk about that we can see when we graph. We'll see all of that. The other thing we talk about is minimums and maximums. The function may have a minimum or a maximum. Now, it could be an absolute minimum, but we also use the word, put here, relative minimum or relative maximum. Same thing here, relative maximum. And that doesn't mean the minimum's cousin came to town and it's a relative. No, relative. That just means for the area. So let me show you on our lesson. There's a wonderful picture that gives you a relative minimum and a relative maximum. So if we look at this graph right here that we have in the lesson, it says right here, this is a relative max right here. The highest point of that curve on the left right there where it says relative max, that is a relative maximum. It's not the maximum for the function, because if you look farther over here, it goes a lot higher. It goes to infinity on the right side. So the maximum for this function does not exist. There's not a maximum, but there's a relative maximum. It means, at least in this area, there's a maximum, because if you go left or right of that maximum, the y is lower. So that's the highest point for the y. It's lower. And then you have a relative minimum over here on the right side, just before 2. Just before 2, because on the left side of it, it's higher on the y, and on the right side, it's higher on the y. So that point right there, the lowest point, is the relative minimum. Again, it's not the absolute minimum, because way over here past -2, it's going down to negative infinity. So if we ask what's the maximum of this, it doesn't really have a maximum, but it does have a relative maximum. So we got to define that and think about the terms relative maximum different than maximum. It's very possible it could be the same thing. If it is the maximum, we just call it the maximum. But if it's a relative maximum, that means there's other points higher, but not right here. This is a maximum that we look at. So we look at that. So increasing, and they give some fancy math terms. If x1 is less than x and x is less than x2, that means the point x1 is less than the point x2. And decreasing and constant. It talks about all three of those, and then relative minimum and maximum. So it gives the official mathematic definitions. And relative extrema. So it uses extrema. So again, relative minimum is an extrema. I mean, that's the extreme. That's the highest point or the minimum, the lowest point. Symmetry. Okay, let's talk about symmetry and even and odd. So I'm going to switch back to my paper for this. Symmetry, we understand. It's like a mirror, right? If we have symmetry, like when we graph x squared on the graph, we have symmetry because everything here is exactly the same distance away from the y-axis. This has symmetry with regard to the y-axis, with respect to the y-axis, right? Because it looks like a mirror. If we take this side and we flip it and look at it in a mirror, it looks just like this side. Symmetry, exactly the same. If we graph a circle has symmetry. If we graph a circle, it has symmetry around the y-axis and the x-axis, right? It's an up and down mirror, just like it's a left and right mirror. Half of it looks exactly the same on the other side. It has symmetry around a lot of lines. The line y equals x, right? If we draw a line straight through it, it has symmetry around that. Any line that we draw through there that goes through the center of the circle, it's going to have symmetry in there. The other big part of this, and this lesson talks a lot about even functions and odd functions. All right, so an even function, odd function. And it talks about testing those and how you know if something is even or odd. If you graph them, an even function looks like this. An odd function, right? And it does have these in the lesson. An odd function might look like this. Even function is going to have both ends of the graph going the same direction. An odd function is going to have one going positive, one going negative. So that goes to positive infinity, that goes to negative infinity. Both of these go to positive infinity. So this is an even function. It could be upside down and still be an even function. But that's how you can tell on a graph. The way you tell algebraically is that if it's even, if we have f of x, it's going to be, let's say we replace that and say, what if we take a negative x and put in there? If we do that and it ends up exactly the way it started, that's an even function. If we take this f of x and we substitute a negative into it, it's going to end up exactly the opposite of how we started. So let's look at that as an example. All right, so let's put an equation out there and test. So let's see if they have one for us to use. Yeah, let's use this one. 2x to the fifth minus x third. Okay, so we've got this function right here. 2x to the fifth minus x third. And we want to know, is that even or odd or neither? It doesn't have to be even or odd. So we test that by testing negative x. So that would be 2 times negative x to the fifth power minus negative x to the third power. So negative x to the fifth power, that's negative x times negative x times negative x. There's the third power, negative x, negative x. If we multiply all those together, what do we get? Negative x times x is positive x squared times another negative x makes it negative again, negative x to the third times another negative x. Now we're back to a positive x to the fourth and another negative. We're back to a negative x to the fifth. So that equals negative x to the fifth. So it would be negative 2x to the fifth, negative x to the third. So negative times negative is a positive x squared, negative x to the third. So minus a negative, minus negative x to the third. And now who are you typing, dear? You have your microphone on. Let's see. So that equals negative 2x to the fifth minus a negative plus x to the third. How's it compared to the original? Well, this was positive, now it's negative. This was negative, now it's positive. So it's exactly the opposite of what it started. It's basically the opposite of what it started at, negative f of x, which means this is odd because everything is the opposite of what we started. This is an odd function. It equals just the opposite. So f of negative x equals that. Now here's the thing. If this had a plus 1 on the end, would anything have changed? Nope, that'd still be plus 1. That'd still be plus 1. That would still be plus 1. Now, this is opposite. This is opposite. This is exactly the same. So in that case, it's neither. Because everything didn't change signs because the plus 1 didn't change. And it didn't end up exactly the same, so it's not even. So if you have this plus 1, it's going to be neither. Without it, it's odd because we did end up with exactly the opposite of what it started with. So anytime you have a constant on the end, it's going to be neither. It can't be the same. It can't be odd anyway. It can't be odd. Could it be an even function? Well, let's check that. Let's check when that would be an even function. So if we go x squared plus 1, let's just make it something simple. X squared plus 1. And we want to substitute f of negative x in to see if it's any different. So we got negative x squared plus 1. What's negative x squared? Negative x times negative x is x squared. So that equals x squared plus 1. We ended up with exactly what we started with, even though we used negative x and substituted it in there. So this is even. So the constant was fine on an even one because we ended up with exactly the same. So we could have a constant on an even function. We can't have one on an odd function. And you can end up with stuff like this equals x squared plus x plus 1. Let's try that one. So if we substitute negative x in there, we get negative x squared plus negative x plus 1. So f of negative x equals negative x squared is positive x squared because negative times negative. And then minus x plus 1. Okay, that's as simplified as it gets with same thing, opposite sign, same thing. That is neither even nor odd. It's neither one because it didn't end up exactly the same and didn't end up everything being exactly the opposite sign either. But that's how we test it. So we can have even, odd, or neither, just depending on what it looks like once we substitute negative x in there. So that is the big highlights of lessons 1 and 2. Again, the lessons look a little bit differently in Buzz this week because it's all on the same screen. You just keep scrolling down, but it does have the practice problems for you at the beginning. In there, it'll say check your answer, will give you a problem, and you can click on there and get the answer. There's not as many on the second one. In fact, I think there's just one set of check your answers on that one. But give this a shot. Go through the lesson. There's more reading and less interactive. There's no videos on module 2 because of where we borrowed it from. So you just need to go through and have to do some more reading and get some paper and pencil and practice these problems as you're going through there. So if you have any questions, get with me. Let me know. Come to class Wednesday if you need to. Most of you will be exempt on Wednesday. Once I get these tests graded, as long as your grade's over 70%, you don't have to come on Wednesday. If it's below, then come see me on Wednesday and we will figure out what we need to do with your grade and answer questions you got and just try to keep you where you need to be this semester. But otherwise, that's it. We have lessons 1 and 2. Next week, we have 3 lessons. So we're starting with 2 lessons. Just get you used to this different way that our lessons presented this time, and then we'll do 3 next time. But that's it. If you have questions, hang around. Otherwise, I will let you go for today and do well.
Let's get out of here. Word to your multiples. Math, baby.